So we are on to our next shape in our quadrilateral unit, which is parallelograms. So we're starting on page 213 in your Springboard books. Make sure you have that opened up and something to write with. So let's go ahead and get started. So a parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. Okay. And just to kind of shorthand this, instead of writing parallelogram all the time, we usually use this little symbol of a parallelogram, and then we can kind of list it. Okay, so if we're talking about parallelogram, K-A-T-Y, we can just use that little symbol to represent a parallelogram. So in that definition, we got our first kind of set of properties here, which is that both pairs of opposite, meaning across from each other, both sides are parallel. So like KY is parallel to AT, and KA is parallel to YT, okay? So let's talk about consecutive angles. So question 1A says, what angles are consecutive to angle K? So remember, consecutive means next to. So next to angle K could be angle Y, okay? Or also angle A is also consecutive or next to angle K. So when we're talking about the properties of those angles, consecutive angles of parallelograms, we're using the fact that these are parallel lines. So for example, if I look at angle K and angle Y, okay, if you look at those angles and you have two parallel lines cut by a transversal, those are same side interior. Okay, same side interior angles. And same thing with K and angle A. Those would be same side if you had another transversal here. But we know same side angles are supplementary. Okay, so that's one property that we're going to know about parallelograms. Okay, that their consecutive angles are supplementary next to angles. The other angles we're going to come from knowing that the diagonal of a parallelogram divides it into two congruent triangles. Okay. So if I have this diagonal GI, that's going to give us triangle, let's say DGI is going to be congruent to, let's say, triangle AIG. You have two congruent triangles there cut by that diagonal. So if that's true, if we have congruent triangles, we know that their opposite sides are also going to be congruent. And so will their opposite angles. Okay. And why is that true? Well, if we have triangles that are congruent, we know that all of these parts are also congruent because corresponding parts of congruent triangles are congruent. So CP-CTC allows us to say that those things are congruent. Okay. So let's move on to the next page here and try some problems. So we're given this parallelogram LUCK. So parallelogram luck. So we're going to use it to answer questions B and C here. So I just recopied these pictures so I can kind of label them nice. But for B, it says solve for X if angle KCU, so that would be this angle here. So if that angle is 10x minus 15, and angle K is 6x plus 3. Okay, well, let's look at what those angles are. Okay, angle K and angle C are next to each other. So these are consecutive angles. So consecutive angles are supplementary. So when I set this up, I'm going to use 6x plus 3, add it to 10x minus 15. Supplementary means I can add them to 180. So let's kind of just clean this up really quick. If I combine like terms, I'm going to get 16x minus 12 is equal to 180. So finish that problem off for me. What does x equal? Well, if you solved everything correctly, you should have got that x was 12. Okay. So again, consecutive angles of parallelograms, so angles next to each other, are supplementary. Let's look at C. It says solve for x and y if KL is 2x plus y. So KL is 2x plus y. LU is 7. UC is 14. And our last side, KC, is 5y minus 4x. They want us to solve for x and y. So we have a system of equations here. So let's talk about what we know about parallelograms. On our last page here, we learned that opposite sides of parallelograms are congruent. So opposite means the ones across from each other. So we can set this up here, take our opposite sides, so say like 2x plus y, and equal that to 14. We can also take 5y minus 4x and equal it to 7. So our opposite sides are congruent to each other. Now let's just solve this system. We can use algebra to solve it, or we might as well use Desmos since we have Desmos as an option. So that's what I'm going to do. So let's go to Desmos and type in our system. So we had 2x plus y equal to 14. My other equation was 5y minus 4x equal to 7. Let's get that intersection point. So 4.5 comma 5. So there's my x and my y. Okay. All right, let's just finish up one last thing with this theorem here that's highlighted in pink. The theorem says the diagonals of a parallelogram bisect each other. So I just drew a parallelogram in here really quick. So let's maybe label this parallelogram. Let's label it maybe RUBY. So parallelogram Ruby. So what we were just told is that the diagonals, let's draw some diagonals in here. Diagonal, bisect each other. So what that means is a whole bunch of things. If they bisect each other, that means they're all congruent. Okay? So if they bisect each other, they're going to cut it into two congruent parts. So if they bisect each other, you have 4 congruent parts there. So that makes it kind of nice that you can just kind of set things equal to each other. Okay, if they bisect each other. Like that. Okay? So let's just do a problem doing that on the next page, and then we will finish here. So in this, number 11, we have parallelogram A, B, C, D. And they say that A, C, and BD are diagonals of the parallelogram, and we're going to find each measure. So we're going to find AE and EC first. So find how you could set up that equation with that theorem we just learned on the previous slide. How could you set up your equation and then solve that equation for y? So go ahead and try that one right now. Okay, so here's what I did. If they're diagonals and they bisect each other, so I can set EA equal to EC. And when I did that, I got y was 5. So meaning if I plug that in, 2 times 5 is 10. Now EC has to be the exact same because they're congruent. So if you find one, you'll find the other. Okay, let's just try one more. We're going to set this one up fine. We need to find DE and EB. So set up an equation to find those, solve for x, and then figure out what the lengths of those segments are. Okay, so again, I just set them equal to each other, and I ended up getting x was 7. So if I plug that into x plus 1, 7 plus 1 is just 8. And if one's 8, the other is congruent, so he is also 8. Okay, so there is parallelogram. So we'll talk about the properties tomorrow in class on our quadrilateral family tree. But there we go.